Hello students, Mahadevan here. Today we will be seeing about how we are going to do a progressive ball bounce. Last class we tried using a ball rig in Maya and we tried to animate a ball in place in the same position from the top to the bottom, again going up and looping it. Okay, so as a next exercise, what we will try to do is we will try to create an animation where will be dropping the ball from some height and the ball will bounce some distance and it will come and stop. Okay, so I'm going to my slides today. So we'll first understand what are the basic things which we need to understand before animating that shot in Maya. Going to my slide. Okay, so there are three balls we have taken today. So one is your metal ball, next one is your tennis ball, third one is your ping pong ball or the table tennis ball. So all these three balls are different in size, different in their physical property. Okay, so the reason why we have taken three different balls is the kind of animation how we need to do will vary independently of each other. Okay, if you're able to do these three balls properly, you can be assured that there are good chances you can animate any kind of animation in the coming classes. So even when you're going for any kind of job as an animator, the basic requirements what a company sees is whether you are able to animate a proper ball bounce. Okay, so that is the amount of detail that these basic exercises requires, because we need to observe real world principles, real world scenarios, and apply it in our animation whenever we are creating it. So many people just see online tutorials and they try to imitate it. So the realism is always lost. So first of all, we'll be taking the heavy metal ball. So coming to its properties, the ball is very heavy. It can be weighing from 1 kilogram to 5 kilogram. So the number of bounce this ball might have will not go beyond 3, approximately, according to my observation, whatever I have done. Okay, so you can also take references from internet, see how these kind of metal balls have been what happens when these kind of metal balls fall. In the coming after I finish this slide, I will also share you videos so that you can also have an understanding of how many bounces each balls have. Okay, so when the metal ball is left in air, the amount of bounce it has to come. For example, imagine I'm dropping a metal ball from here, it goes down, so there are no chances that the metal ball will jump so much high. Okay, so the maximum possibility is if I'm dropping from this line, the metal ball will try to come down here, it hits the ground again and maximum goes up a little, falls again, falls, it stops. Okay, so maximum 3 bounces it might have. Okay, so in this way, we need to observe how each and every ball is bouncing. So for example, for a tennis ball, so if I'm dropping from here, a ball might take a curve like this. It will come down, it hits the ground. Next one, due to its elasticity, the ball might jump a little bit more in air. It will take an arc, come back, again hit 2, and again it will bounce 3, 4, 5, 6, 7, 8, 9, 10. So it will go on like that. So it depends upon. So what I would suggest you is I will also share you some videos. If possible, if you have these kind of balls in your hand, you people can put the ball from a distance in the air to the ground without without giving any force. Just leave the ball so that you see how many bounces this ball is making. Okay, so approximately a tennis ball might have a bounce of from 9 to 11. That's my observation. And when coming here, a table tennis ball is very unique. So when you drop it, it bounces very high, and the amount of energy with which it bounces is also very fast. Okay, and moreover, when it's coming to its end, you can hardly see the bounce happening here and there. So it will be like very fast, okay, in the ends. So calculating the number of bounds when it's coming to a standstill at the end is going to be like very crucial part. Okay, so approximately a ping pong ball might have 20, around 20 bounces. Okay, so only if you're having these amount of like bounces, there are chances that you might feel that these kind of balls are gonna be like realistic. Else, if you're animating directly in Maya without observing these kind of things, will not be able to feel it. So a ping pong ball will not have a large amount of will have a large amount of hang time in air when compared to that of a metal ball. Okay, so because it falls down, it slightly goes up and again comes back, so it doesn't have a hang time, this metal ball. So rubber ball has a minimal amount of hang time. So ping pong ball, just being like a very light kind of ball, has more amount of hang time in the top, but when it comes down, it comes with a good amount of energy. Okay, so I'll go to the next slide. I'll show you the basic keyframes that is required for a ball bounce. Okay, so here we have a Maya progressive ball bounce. So this is just for your understanding and example. So we'll see how many bounces a normal ball bounce is having. So here we have 1, 2, 3, 4, 5, 6, and 7. Totally 7 bounces they have created. So in last class, what we have seen is, in order to create a one complete bounce from here to the top to the same level, we kept 9 keyframes, if you can remember. Okay, so here, just observe here, from this half position to the ball to come down, we have all the keyframes. This is your keyframe, this is your ease in. So ball is getting momentum, it's coming, it's stretching, maximum stretch here, you have the squash. So all the keyframes we have already created it, so which we saw in last class. But see what happens when this ball goes back to its normal position. So here 3, 4, 5, 6, 7, totally 7 keyframes are used here, but it's going back, they have hardly used 4 or 5. So when you go more and more and more, see the number of keyframes in order to create this kind of animation is decreasing one by one. Okay, can you see here? So 1, 2, 3, 4, 5, 6, 7, 8, just 8 keyframes here. So here for this bounce, 1, 2, 3, 4, 5, 6. So 2 keyframes is totally lost when compared to this one. Okay, so this 2 is here. See this hang time, they are totally taking it. Can you see? Only the middle part is available. Okay, so the reason behind it is, when the distance or your timing between one Boeing to another Boeing is very limited, you cannot keep many number of keyframes. Okay, so when the timing reduces, your keyframe inside your animation also reduces. So when I compare this bounce to this bounce, see how many keyframes. So it's going up, again having a hang time, again coming down. So the next keyframe down, only one keyframe, just up and down. Okay, so more elaborate animation would be there in the first 3 bounces, maximum 3 to 4 bounces, and it also depends upon the kind of ball you are animating. For a metal ball, what happens here is, you will be having this first bounce followed by this 2 and 3, so you will not be having this animation at all. Okay, so this 2 animation will be totally cut off. Metal ball will not have a slow in, so it will come down very fast. It hits, it goes up little, comes down, again it settles down. Okay, so this animation will be totally taken off for a metal ball. For a rubber ball, the amount of bounce will vary accordingly. So you also need to understand from the first level how much amount of height the second bounce is taking in. So a table tennis ball will have a more amount of bounce than a normal rubber ball. So, and so forth. Okay, I'll also show you some videos or references by which we'll be able to understand how people have done ball bounce. Okay, so this is a ball bounce where we can take this as your rubber ball. This one can be your heavy ball filled with air. This can be your ping pong ball. Can you feel the amount of speed with which it comes out? This can be your metal ball. So this is it. This is your balloon. Okay. But the problem here is uh, I just downloaded this from internet. The person who has animated this, uh, to comment on it. Ball comes, it starts, hits. Okay. Can you see any squash or stretch, which is not at all applied? So those kind of concepts are missing. So this is what I've been telling you people. So if you are gonna be applying for any kind of organization for a company or any kind of production unit, people will be seeing whether you have applied all the principles there. So if you're not applying it, the kind of animation, even if you are doing it good, it will not be accepted. Okay, so see, it's touching the floor, and right now it's coming, stopping. Okay, fine. Next one is your this ball. Okay, ball number 2, ball number 3. See how the ping pong ball suddenly stops. 1, 2, 3, 4. It feels like it's sticking on to the floor. Okay, so don't we should not animate in such a way. When you play any video, you will be able to notice how the animation, sorry, how the movement of ball is. So just observe here. When the ball stops, it stops very abruptly. It doesn't look nice. Same way for this metal ball, when it's coming down, just play it again here. So just play it, see, it's rotating in the same place. Can you see? We are working in every frames, so the amount of detail, whatever you do, needs to be like proper. So it bounces, goes up. See, the rotation is more. It feels like uh, the car wheel is skidding in the same place. Okay, so that kind of feeling should not be given for a metal ball, which we'll be discussing in detail when we are adding micro details for your animations. And the biggest blunder I would say is this balloon. It doesn't feel floaty, like it's like floating in the air. Okay, so which you will also observe it. It's like someone has thrown it. It comes, hits, suddenly it becomes slow, suddenly it becomes faster. So again comes down faster. So this is totally wrong. So I'm just showing you how people do submit portfolios online for jobs. So these kind of problems can be avoided if we understand the concepts better. Okay. Okay, one more thing. See the comparison in this one. This is a better animation here. So this has more fluidity here, and this is how a metal ball should come and stop. Okay, the weight. So it should not stop abruptly, or it should have a very kind of smooth kind of settling. So see for the number of frames they have animated here also. Okay. I will also be sharing these files so that you can observe this and make the ball bounce accordingly. Okay, this one. Okay, so the next one is your ping pong. Okay. So here is a video reference for a ping pong ball. See, you can calculate the number of bounce it takes, and also compare how much height is decreasing for each and every bounce, so that you can understand it. For example, it's like one, 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 one. Okay. So by observing this, you will be able to create better animation with regard to reality. Okay, that's the reason, like, I just wanted to show you these kind of video references. First thing, most important thing as an animator is observing movements happening in real life scenarios and trying to recreate it in your software. Okay, if you fail to observe things, there is no other shortcut in order to like create good animation. Okay, so this for your ping pong ball. Okay, one more. You can calculate the number of bounces. Okay. One more thing, what I would like to say with regard to any kind of ball bounce for that matter is, irrespective of the height from which you drop a ball, the timing of the number of bounces will mostly remain constant. For example, you need to keep your hand straight, stretch it outside your body, and just leave the ball from your hand. And if you calculate the number of bounces that happens, and if you slightly reduce the amount of height and leave it for the second time, the number of bounce will not change. So this is called as your timing. For example, if a person asks what's the timing for a rubber ball, you should be able to say like some approximate number which is equal to reality. Same kind of concept goes even with your ping pong ball. So someone asks what is the amount number of bounces for a ping pong ball, you should have observed it. Okay, so which will be almost a constant. That's the reason I'm showing all these things to you. Next one is your rubber ball. See the bounce that's happening here. Hope this will be helping you to create your animation possibly. Okay. So see the height difference, how the height is decreasing one by one. It's coming down, coming down, coming down. So also calculate the number of bounces that is happening. So let us try to recreate the same kind of bounce in today's class. Okay. So first we'll try creating the bounce with this rubber ball. Then we'll start going on with the metal ball. Okay. So I'm stopping here. Let's give it a try.